Hi, all. Welcome to another interview preparation series from Geeks for Geeks. Our guest for today is Smriti Naik, who is a student of International Institute of Information Technology, Bhubaneswar. And she will be interviewed by our in-house mentor, Yash Dwivedi. We'll be starting soon. Meanwhile, I'll request you all to invite your friends to the webinar. Okay, people are joining in. Just give a thumbs up in the comment section so that I know that there is some engagement. Okay, I'd like to invite now Yash and Smriti. Hi guys, how are you?
Hi, Jay. I'm fine. How are you?
Good. How are you, Smriti, today?
Hi, I'm fine. I'm good.
Okay, so we can start the webinar now. Yash will take the lead, and Smriti, best of luck.
Thank you.
Sure.
Okay.
Hi, Smriti. Can you please introduce yourself?
Hi, I'm Smriti. I'm from Triple IT Bhubaneswar. I'm currently in third year, and I am a CSE student. Uh, I'm practicing the data structure and algorithm problems, and also I enjoy doing web development using MERN stack, and I have participated in many hackathons, and through which I have done many projects. Recently, I participated in Flipkart Grid, through which our team has made a website called Conversational Chat Application. Yeah, that's it.
Okay, so can you tell us something about your project, your best project that you have made so far?
Yeah, as I've said, I have participated in many hackathons, one of which is She Hacks. In that hackathon, we have made a project called Jagriti, in which uh, anyone can get information about hackathons and contest, and can get updates through email, and also they can post their inspirational stories to other members of our community to inspire other students. And we have made that project using Stack. And in another hackathon, as I have mentioned, Flipkart Grid, in that hackathon we have made a conversational chat application using React chatbot kit. It was mentioned to use that tech stack only, so we have made it. Yeah.
Any particular reason? I can see that you have done a lot of development in React and MERN stack. So, any specific reason for that? Why not choosing, let's say, Angular or Vue?
Like at first I have learned JavaScript, and after learning JavaScript I found that for front end React.js is very easy to learn. And also the feature of React.js, that it is, we can reuse the code, and also it increases the readability of the code. Anyone from anywhere can understand our code easily. Like the same code is used again and again, same components can be used in by using various elements. So React is very useful in that case, so I chose React for that
Okay.
reason.
So, since you know that this will be a DSA based round, so I'll be asking you two questions from related to data structures and algorithms, and I've just shared the Google Doc with you in the chat. So you can just can you just open that and share your screen?
Yeah.
So we'll be discussing two DSA problems, and based on that, I'll be giving you a feedback in the end. You can just share your screen with the doc. There will be a share button right down there.
Is it visible?
Currently, it is not. Yes, it is visible now. Yes, right, it is visible. Okay,
Okay.
so moving to the first question for today. So Just can you just increase zoom in a little bit so that it is visible to everyone? Okay, perfect.
Is it
You can
fine?
just zoom out. Yes, yes. Okay, perfect. Right. So, what you have to do in this question is you have been given, like you have been, there are n stairs. Okay, there are n stairs, and a person is standing at the bottom. That is, he is not standing at any chair. He is standing at the bottom, and there are total n stairs. And what you have to do is, this person wants to reach the top, right? So the person can climb either one stair or two stairs at a time, right? Either wherever he is, let's say he reaches some stairs, let's say he reaches the second stair, so from that stair he can either go to the fourth stair or either he can go to the third stair, right? So either he can
Okay.
take one step or he can take two steps. This is how he'll be doing. So you have to count the number of ways in which this person can reach the top, right? So let's say if n is equal to 2, right? If there are two stairs, then what he can do is, first of all, he will be at the ground level, right? So he'll be taking
Yeah.
first step. He can take one step and he can reach the first stair, and after that he can take one step again, and he will be reaching the second stair, right? Another thing that he could have done is he could have directly climbed two stairs, right? So in this way, in just one step, by climbing two, he could have reached the second stair, right? So you can see that there are two ways: either going 1 comma 1, that is one stair and then one stair, or either directly going two, right? And is this test case clear to you?
Yeah. Yeah. So the person has always two choices. Either he takes one step or or otherwise he takes two steps.
Yeah, right.
Yeah.
So basically, if we look at is the first test case clear to you, first of all?
Yeah.
Right. So moving on to the second case. For the second case, you can see that n is equal to 4, right? So the state that
Yeah.
he has to reach is 4, right? So what he can do is, either he can take one steps, that is 4 times 1 steps, and he can reach the 4 stairs from the ground level, right? Either he can do that,
Yeah.
or he can take one step and then again one step, and then after he reaches the second stair, after taking one step each, he can take two steps and he can then reach the fourth stair, right? Is this
Yeah.
second way clear? After this, one
Yeah.
thing more that he can do is that he can take two steps, and he will reach n is equal to 2. After that, he can take one step each two times, and he will be reaching the nth stair, right? This can
Yeah.
be one of the ways. Another way can be that, let's say he climbs one stair, then he climbs two steps, and then he climbs one stair. In this way also he can reach the fourth stair, right? Another way can be that he takes two stairs and then he again takes two climb of two stairs, right? So in this way also he can reach and n is equal to 4, right? And if you count all these ways, so there are total five possible ways to do this, right? So you will be given a value n, that will be the stair value, and you have to tell that what are the total number of ways in which you can reach the nth stair. Okay.
Okay. Okay.
And in one climb, either you can climb one stair or you can climb two stairs.
Okay.
So is the question
So
problem statement and all the test cases clear to you?
yeah. So what will be the constraints of n?
um let's say that the constraint for n initially can be, you can think of it as 10 to the power 3 initially,
Okay.
or you can say
So
10 to the power 4.
yeah. So here I think like in every case, like while the person was climbing on the stairs, like he has two choices. Like he can climb one step or two step. So as here choice has encountered. So I think here recursion will be used. So by doing recursion at the end when he reaches the top, we can increment the value. Like I'm
Okay.
currently in my mind, I am getting the approach of recursion. Can I try it?
Yes, sure, you can try it.
So let the name of the function be count. Uh, okay,
Yeah, right.
function be count, and it will take the value of n, which will be provided by the input. Okay.
Okay.
And first I will write the base case, that is if n is equal to 0, that is there is no stairs left. In that case, the person has reached the top of the uh, like he has reached the destination, so we will return 1, like, because there is only one possible case, like he can reach the top of top of the stairs, so we will return 1. After that, when n, like if n is greater than 1, greater than 1, then we will return count of n minus 1 plus count of n minus 2, because for when n is greater than 1, he can either take one step or two step. So and in both the cases, the steps in both the cases, we will add both the value which will be returned from the two functions, that is count n minus 1 and n minus 2. And for value less than n or equal to n, in that case we will return count n minus 1.
Okay, so do you
and
think that this will work?
And for another case, when n is less than 0, we will return 0, because in that case we can't reach the top of position. Suppose if we do if the person takes two steps at each case, he can't reach the top, because if the value of n is 5. So in that case, we will return 0. And for other cases, when n becomes 0, we will return 1.
Okay, so do you think that this will work?
Can I check it once? Like, I have not checked it.
Sure.
Yeah. So for 5.
Whatever you are thinking, you can just tell me about your approach at the same time, right?
Like, I'm just taking the case when n is equal to 5. So when n is equal to 5, uh, n is greater than 0, so it will go to the same function having
Let's
value.
take the case which has been given to us already. That is n is equal to 4. And can you try to generate all the cases for that?
Okay, so when n is equal to 4, as n value of n is greater than 1, it will go to other function, that is n is equal to uh, n is equal to 3 and n is equal to 2. And in that case, for n is equal to 2, for n is equal to 3, uh, it will again go from n is equal to 2, and n is equal to 1, and n is equal to 1 will return 1, because when n is equal to 1, it will return 1, and for n is equal to 2, it will return 2. So for n is equal to 3, it will return 3 cases.
For n is equal to 2, you are returning 2. But where does that happen in the code part?
Okay, so for n is equal to 2, as n is greater than 1, so it will count n is equal to 2 will give n is equal to 1, and and n is equal for n is equal to 1 and n is equal to 0, and n is equal to 0 will return 1, and n is equal to 1 will again go to n count n minus 1, that is n is equal to 0, which will return 1. So the final value when we return from n is equal to 2 and n is equal to 1 and n is equal to 0, it will return 2.
Uh, are you sure? Because if n is equal to 2, then in that case it will be going in this if, right? Which is n is greater than 1.
Yeah,
So, okay, right,
like,
perfect.
yeah, so n is equal to 2 will return 2, and n is equal to 1 will return 1. So the final value of n is equal to 3 will be 3,
Okay.
right? And the value of n is equal to 2
So basically, you
will,
are trying to go top down.
yeah, top down from,
You are trying to get the answers for the smaller cases, and in this way, you will be building the answer for the
yeah,
nth state.
yeah. So for n is equal to, like, I have calculated the value of n is equal to 3. Then for n is equal to, we have already calculated for n is equal to, that is uh, that is 2. So the final value will be 5. Therefore the output will give 5 after adding those two functions of count.
Okay.
So this will
So,
be the recursive approach.
what will be the time complexity for a recursive approach like this?
uh, as in this case, for each case I am using 2 more recursion, so its time complexity will be 2 to the power n.
Okay. Do you think that we can further optimize it?
Yeah, I can memorize it using a vector. uh, a one a 1D vector will be helpful. So
Okay.
I will create a vector having value int, because the value of n is less than 10 to the power 3 in the constraints. So let it be dp, let its value be 10 to the power, and all its value be minus 1. Initially it will be initialized to minus 1. So as the final maximum value of n is 10 to the power at most n to the power 3, therefore I'm taking 1000 1005, and
And why?
at,
What is the reason that we initialize it with -1?
because I'm checking in dp, I will store the value of which I have already evaluated. So when I encounter the same value n, so I can figure out, like, if it is have value which was not minus 1, that means I have calculated, therefore I am taking a value which will be which cannot be the answer in this case. So for checking purpose, I am using -1.
Can
Okay.
you one thing that I want a clarity on? Like as you said that you will be evaluating a couple of states or a number of states more times, right? That is what you
Yeah.
are saying. So can you give an illustration, a little bit illustration about that? Taking some value of n.
Like in this case, when n is equal to 4, we have, for count n is equal to n minus 1 and n minus 2, we have to calculate for n equals to 3 and n is equal to 2 both. And again for n is equal to 2, we have already calculated the value for n is equal to 2 in the case when we are calculated for the n is equal to 4. So to like we are evaluating for the same value again and again.
Okay,
Therefore I am using this dp vector.
okay. You can continue, right? Deepu.
So here in this case I will check if the value of n, if the value of n is not equal to -1, I will simply return dp of n. And for all the case where I'm evaluating the value of n, I will in I will initialize the value of n to the to the value which I am returning.
Okay,
Yeah.
right. Uh, what will be the time complexity of this code?
Like in this case, I'm evaluating for the each value of n. So and I'm doing it for only once. Therefore, the time complexity would be big of n, I guess. Big of n.
And will there be any space complexity for this code?
Yeah, it will. Space complexity will also be big of n because we are
Why?
using a vector dp. No, the
Okay.
space complexity will be constant here because I am using a constant value
No,
1000.
no. Basically, it will be you will be initializing it to n, right? N plus one, right? You'll
Yeah,
be
yeah.
initializing your DP to n. So that is why. What will be your space complexity in that case?
In that case, also the space complexity would be big of n.
Okay, right. And is there any other auxiliary space for using recursion or anything for your function?
Sorry,
Uh,
I'm
is
not
there
able to.
any other space that you are taking? Like the count function? Is it taking any other kind of space?
Yeah, it is using stack. Like we, as I am using recursion, therefore the stack space is used. Like we are
Okay.
storing the recursive value in stack, so internally stack space is used. Heap.
So basically, in this code, what you are trying to do is you are trying to first of all find the smaller, like you are trying to do from a top-down approach, right? For the you are trying to find from the top down, right? You are trying to
Yeah,
first determine the let's say n minus one and n minus two state, and then you will
yeah,
determine the nth state, right? Moving top
yeah,
down. So can you do this in a bottom-up manner, like in a tabular form?
yeah,
Can we do this?
yeah. We
Can you
can.
write?
I can. So for that, I have to use loop. Can I remove this code? I write the
You can
another
write it
code.
below. You can write it below. You can do not need to remove it. You can remove this n is equal to 4 and all this part so that it is much better.
So for, at the beginning, I will declare a variable dp as I did in that case, and that let the size of dp be n minus n plus 1, and initially I will initialize it to value 0.
Why not minus 1 in the like you did in the previous code?
In the previous code, as I am using recursion, so I'm checking minus one, like its value is already evaluated or not. In this case, I'm using 0 because at the beginning of, like, I'm going from bottom up approach. So when the stairs value is 0, like the person don't have to climb. So in that case, the number of cases will be 0 for n is equal to 0. For that case, the dp of 0 and dp of 0 will be its answer will be 0. So, and for further value of n, I'm changing its value according to its previously calculated value.
Yeah, right.
So for, yeah,
So basically, in this code, you will be trying to go from a bottom up, right?
yeah, from smaller value to larger value. So for I is equal to 1, and I will continue this loop from I is equal to 1 to uh, n value, and increment, sorry, yeah, okay. So I've already initialized the value to 0, so I don't have to initialize for I is equal to 0. And for all those cases, when if I is equal to 1, that means only one stair is there. So for
Right.
that case, dp of I is equal to dp of I minus 1 plus 1. And for all other cases, dp of dp of I dp of I is equal to dp of I minus 1 plus dp of I minus 2.
Okay, so let's say the n value is 2. So in this case, dp of 2 will return the value for the second stair, right? But what will be your value for the second stair in this case?
Here for I value equal to 2, it will return 0 in the code which I have written. For that case, I think I should initialize it to 1, because when the number of stairs is 0, uh, we have only one case to reach the destination. And when I value of I becomes less than 1, for that case, the value will be less than 0, I think.
Can you think again? Like, are you making some mistake, or will it work?
P of I, dp of I minus 1, minus 1 plus dp of I minus.
Let's say for n is equal to 4, what will be the output? Let's try to do a dry run here. Let's say n is equal to 4, then what will be the value for dp of 4?
So for n is equal to 4, uh, for value 0, I have initialized it to 1, and for value 1, I will calculate dp of 1, that is dp of I minus 1, that will return 1 only. And for value 2, it will calculate for dp of I minus 1, that is 1, and dp of I minus 2, that is 0. So for that case, dp of 1 plus dp of 0 will be 2. Then dp of 3 will calculate the value of dp of 2 and dp of 1. dp of 2 and dp of 1, so 3 will return 3, and dp of 4 will return 5. Yeah, it is giving correct answer.
Okay. What will be the time and the space complexity for this type of code?
The time complexity is big of n, and also the space complexity is big of n.
And is the function using any extra space itself?
Like it is only using this dp vector space, that is big of n, and no, instead of this, it is not using any other space.
Okay. Right. So this question is done. Can you scroll down a little bit?
Is it fine?
You need to scroll down a little bit. The second question is written down there. Uh, can you scroll
Okay,
down a
okay.
little? Yeah, right. So can you zoom in? Okay, perfect. So I think that the question must be visible. So
Yeah.
let me read the question for you. So the question says that you have been given an array of integers, and you have also been given a number k. So you have been given an array which consists of n integers, and you'll be given a number k, and you have to count the number of distinct elements in every window of size k in the array. Okay, you have to count the number of elements which distinct elements in every window of size k, right? So let's say that the first window will be what? For this case, for this array, the first window will be 1, then you will have 2, then you will have 1 and 3, right? This will be your first window. So for this window, what are the total number of distinct elements? 3, right? So that is why you have written
3.
3 here. Now next up, what will happen? The new window will be 2, 1, uh, it will be 2, 1, 3, and 4, right? So for this, you can see for the second window, you are having total 4 distinct elements. So that is why you will write 4 after this. After 3, you will write 4, right? After this, you have 1, 3, 4, and 2, right? So in this case, you can see that there will be total 4 distinct elements again, right? After this,
Yeah.
what you'll be doing is you have 3, 4, 2, and 3 in the next window. And you can see for this window, 3 and 3 are same, 4 and 2 are different. So that is why you have 3 distinct elements, that is 2, 3, and 4. So the total number of distinct elements for this case is 3, right? So is this test case clear to you?
Okay. Yeah, I understood.
Right. Let me show you, let me do a dry run for the second test case as well. So for the second test case, first you will be having window size 2, right? So first of all, you will be having 4 and 1 in your first window. And you can see since both these elements are distinct, so that is why total number of distinct element in this window of size 2 will be 2, right? After this, once you move your window, so for the next window, the of size 2, the array will look like 1, 1, right? So in this, you have only one distinct element, so that is why after that you are just writing 1. Okay, is this question clear to you?
Yeah, it's clear.
Okay, so how do you think that we should approach this question?
Like, I was thinking, I can use a set data structure. In set data structure, only distinct values are stored. Like we can't store duplicate values in set. So I will declare a set data structure, and in set data structure I will insert the elements of the array until its size becomes 4. After, when the size becomes 4, i will uh, I will output the size of this set data structure, and after that I will remove the element. Like, I will initialize a pointer pointing to the first element of the array, and I will remove the first element of the array, then move that pointer to the next element, and I will initialize another pointer which will uh, point to the element having where the size of vector becomes k, and I will include the next element into the set, and each case I will output the size of the set vector.
Okay, so what will be your time complexity for the code in that case?
Uh, Here in that case, I'm using set vector, and in set vector, for inserting and deleting, it takes big of log n time. Big of login time, and the size of the vector is always equal to k. So the for inserting and deleting, it will take big of log k time, and I am doing it for each and every element of the array. So for that case, its total time complexity will be n log k.
Okay, so can you write the code for that?
Yeah. So let the name of the array count distinct, and it will take two values n and k. First, I will declare a set vector. It will have value of int, data type, let it be st.
You can just scroll a little bit up so that your code is visible. Okay, perfect.
So I will initialize two pointers, p1 and p2. P1 will point to the first element of the window, and p2 will point to the next element of the window, next when the window uh, completes. So p1 will point to 0, and I will initialize afterwards when I insert all the elements into the array. And here I have to use another variable, that is array. I will name it as array. So is equal to 0 while I is less than k. St dot insert array of I plus plus. And when all the elements having uh, within the size of the window are inserted, after that I will continue a for loop. I will
Okay.
continue a for loop and initialize p to k. p2, sorry, p2 to k.
Okay, so you are considering a zero-based indexing.
Yeah, and the for loop will continue from p2, as I have already initialized p2. So for p2 less than n and p2 plus plus.
Okay.
And for each case, uh, as our window is already filled with k elements, uh, I will first, like, I will store the answer in another vector, like it will return a vector. So sorry,
Okay. Right. It should return a vector only.
it will return a vector, and I will initialize a vector called answer, in which I will store all the answer. So in answer vector, I will push back the size of the set. Uh, After inserting the size of the set, I will delete I will delete the last, like the first element of the window of size k, and for that I have to create a iterator. So for creating a iterator,
Uh, don't you think that you can use P1? You have used P1, but you have written P1, but you haven't used it.
like p1 can be, yeah, p1 can be used. So we- I will erase the value having the index p1, and I will insert the array having index p2, and this loop will continue until p2 reaches the end of the array, and after that I will return the answer.
Are you making some mistake in this code?
uh, p2 is less than p2 plus plus.
Just bring the complete function down in a single page so that everything is visible. You can just click on enter and okay, perfect.
P2 is equal to k. P2 is equal to k. Insert array of I plus plus. Didn't
You can remove
answer.
this P2 initialization. You have initialized two times P2 with K, so
Didn't answer. P2 plus plus.
okay,
I have to
let's
return
try
this.
and dry run this on the sample
Yeah,
case.
yeah.
Just copy the sample case. Or let's say I give you a sample case. Let's say I give you, or you can take the sample case from. Let's say I give you a sample case. Okay. So let's say I
Okay.
give you 4, 1, and 1 only, right? 4, 1, and 1. and n is equal to 3. 4, 1 and 1 is the array, right? 4, 1 and 1 is the array.
4, 1, and 1.
Yeah, right. And the window size is 2. K is equal to 2.
Yeah.
Yeah, right. So how
So,
will we doing this?
so
Let's take
first,
another element. Let's take one more element. N is equal to 4, and the last element would be 3. Now
okay.
let's try and do a dry run for this.
So first, I will run the while loop. In the while loop, I will insert the elements into set until the value of I is less than k. So in this set, initially I have value 4 and 1. Okay,
Okay.
and p will be pointing to 0, and the p1 value will be 0 initially, and p2 value will be 2. After that, I will continue to the for loop. In the for loop, uh, the value of p2 is 2, so it will be pointing to 1, pointing to the pointing to the 2 number index, which will have the value 1. So for
Okay.
that case, uh, I will insert, like, push back the into the answer vector having window size 2, and after that I will uh, erase the value, that is 4, having index value 1. Okay, I have not incremented the value of, like,
Right.
uh, then I will increment the
Don't
value
you
of
think that
p1.
every time you would have been erasing the first element, right?
Yeah, yeah, like,
Okay.
I
Do you
forgot
think
to
is there any other mistake or is this code fine?
yeah, it's fine. I think now it's fine.
Okay. What will be the time complexity for this code?
uh, for this code, the time complexity is big of n log k.
Okay. Can we further optimize it
uh,
from big of n? Okay. Can we further optimize it?
4 1.
Whatever you are thinking, just think that out loud.
Mm. Okay. Like, if I know the constraints of n, if I know the constraints of n, uh, 1 minute. If I know the constraints of n, like, if the value of n is all positive values, then I can create a vector, like, not vector. I can use a unordered map, and uh, like, unordered map or unordered set, and for that case, unordered map insertion will take, like, for that case also it will take log k time.
Okay, what if the constraints of n are very low and the all the elements of the array are between, let's say, 1 to 10 to the power 4? In that case, what can we optimize it? If all the elements are between 1 to 10 to the power 4, in that case, can we optimize it further?
1 to 10 per 4.
Normally, what is the time complexity for insertion in a unordered map?
Like for unordered map, I don't remember inserting and deleting. I think it is log n, and for
Are you sure?
finding it,
Then what is the difference between a map and an unordered map?
like I don't remember. Like unordered map, uh, like an unordered map for finding it takes big of one time. For inserting and deleting, I think it takes less time than the map.
Let's say that I give you a situation where the elements are between the range 1 to 10 to the power 4. In that case, will you again use an unordered map or a map, or can you do it in a much simpler manner?
Like in that case, I can, like we are not having key or value pair, so we can use unordered set.
What I'm saying is, let's say I decrease the constraints more. Let's say all the elements of the array are between 1 to 10 to the power 3. They are between 1 to 1000. Now in this
Okay.
case, do you need a data structure like a map or a set, or an unordered map or an unordered set, or can you do it in a much simpler manner?
We can create a vector of size 10,000, and
Okay.
but for that case we can't uh, calculate the size of the window. It will, like we can calculate, but it will take much more time to
Why do you think
calculate.
so?
Like I'm thinking
Let's say
of the
let's say I allow you to use an unordered map. Then what will be the time complexity? Assuming that unordered map is taking, let's say unordered map takes constant time. Okay,
okay.
forgetting about unordered map, what if you are using an unordered map? Then what will happen? Like, what will be the time complexity after that?
Uh, if I use unordered map, unordered for inserting, it will take less time, and
Don't think about what I'm saying is, let's say that I allow you to use the data structure that you want, right? And
okay.
let's assume that it has some complexity, whether it can be constant or anything. But what will you after that? Basically, you want to do the hashing part. So let's say I allow you to do that. What will be your approach after that?
Like I
You
will
wanted to
store.
you wanted to use a map or an another map, right? So you can do
Yeah.
that. But what after that? What will you do after that?
Like after that, I will do the same thing. Like I will calculate the size of the map and erase the first element from the map, and and insert the next element into the window.
Okay, and let's say I ask you to use a vector where the elements are between 1 to 10 to the power 3, right? So can we
Yeah.
use a vector instead? If we are using a vector instead of an unordered map or a map, then in that case, what would happen? In that case, how will you implement this?
In that case, like I'm using a hash map of vector, and at each point I am increment, like for each value of array I'm incrementing its value in the vector, and when I'm inserting new vector I will just increment it, and when I erase I will just decrement it, and when the value becomes 0 I will
You will be
decrease the
keeping a
size.
counter.
Yeah.
You will be keeping a count for the distinct element, right? So can you just quickly implement that part using a normal vector?
Like using a normal vector, uh,
Yeah.
as
Let's say the number of distinct elements. Let's say the number array of elements can be between 1 to 10 to the power 3 only.
so I will name it as frequency, and it will have a size 10, like the maximum value of array is 10 to the 1000, so I will take 1005, and all will have value 0. Then I will increment the frequency of that particular element having index I, and I will first calculate the size of the frequency, like from end I is equal to 0 to I less than 1005, I plus
But
plus.
in that case, if you are doing this, then your time complexity will be 10 to the power 3 into n, right?
Like I'm doing it for only once to calculate the initial answer. Like in first in this loop, I will I will take account account value, which will be 0, and for each case when the frequency value of I is greater than 0, I will increment the count value. And at the beginning of this, I know the answer, so I will just insert the count value. and at and after that I will decrement
That
the
is perfect.
frequency.
I This can be done, right? It will be 10 to the power 3. Let's say n value is also 10 to the power 3, right? So in that case, it will be 10 to the power 3 into 10 to the power 3, right? Your complexity will be like this, right? So what is the use of hashing in that case? Can you think a little bit more? Like if when you are incrementing the frequency, can you keep a counter, and can we do something with a counter? That is what I'm saying. You are trying to count it like this way, but let's say when I am counting, when the moment that I get a new element and I am counting that the ith element, so in that case what will happen? Can we do something? If we get a element for the first time, if we count it and its frequency increase, its frequency is 1, in that case can it help? And when we decrement the frequency for the leftmost element that is not currently in our window that we just left, we just slide a window by one, and we just left that particular element. So in that case, will it be can we use these two properties or these two points?
Y- yeah, for that case I'm saying that uh, if the frequency value is if the frequency value of array of p1, I'm doing the same thing, if the is equal to 1, or if its frequency is equal to 1, then I will decrement the count value. And
So you don't need this loop, right? The loop from 0 to 10 to the power 3. Are you getting this point?
uh,
If an element comes for the first time, right? If an element comes for the first time in your map, then that means that the total number of distinct element increase by one. And
yeah,
if the current element that you are removing, that you are decrementing frequency, of which you are decrementing the frequency,
yeah, yeah.
uh, you are removing it, right? If its frequency now becomes 0, so that means the total number of distinct elements are now removed, right? Are you getting this point?
Yeah,
Okay.
I understood, when the value becomes equal to 1, the size becomes 0, but I don't get why we don't need
Uh,
that
let's
loop.
let's let's say I use a count. Okay. I Is my changes visible? Are my changes visible?
Yeah,
Right. Yeah. So
yeah, yeah,
let's say I'm doing this. I do this. This is what frequency of size. Let's say that is the size. Frequency size will tell me what? Will tell me the total number of distinct elements after pushing the first window. Right. After this, what I can do is I since I have the first windows. Right. I have the first window, so I can simply push it into my answer before starting the loop, right? I'll simply push back the first window size as from my count, right? And once I have
yeah,
done that, so what will I do? I come into this array, and what I'll see is that if let's say I have started, and if my ARR of P, if let's say ARR of P2, if ARR of P, if frequency of ARR of P2
P
P2, if it
P1,
is if it P2, right, the current
yeah,
element, if the current element that we are adding, if it is 1, if it is 0, then what you will be
yeah,
doing? You will be first of all incrementing its frequency, right? You will be incrementing its frequency by 1, and you will be also doing
yeah,
a counter plus plus, because the number of distinct
yeah,
element will increase, right? This is what you will
Yeah.
be doing. Basically, you will be
Yeah.
doing this, right? You'll be doing this, right?
Yeah.
After that, there's one more thing, that before pushing answer, you won't be pushing your answer directly, because you will be
Yeah.
checking that if the current element that you are removing, if that, and you'll also be doing a plus plus. So the current P1 element that you are removing, if its frequency was 1, then in that case what you will do is, your number of distinct elements will decrease by 1, and also you will be decreasing the frequency of the current element, right? Frequency of
Yeah.
ARR of P1. And you will be doing, let's say you do this P1, and you do a plus plus here somewhere, P1, and you do a plus plus, and after that you decrement its frequency, right? So in this way
Yeah.
it can be done in order of n time instead of n log k, right?
Yeah.
Right. So this was it from my side. Do you have any questions for me?
Like as you have in this case you have initialized the count value to frequency dot size, but the size frequency value is size of frequency is 10 to the power 3.
Oh,
Like
okay. Yeah, right. So this is not a map. So in that case, what you can do is, right.
we
I
can
thought
use
that
map.
you, okay, if you want to, the alternate way for this will be that, if you are doing this, then if, for whichever element
Huh.
frequency of ARRI, if it is 1, after incrementing it, if it is equal to 1,
Yeah.
then you can simply do a count
So
plus
we
plus,
will
right?
yeah. Yeah,
So in
understood.
this way, you will be able to count all the distinct elements, right?
Yeah.
And you are not decrementing anything. So that is why a particular AI element, ARRI, distinct element will be counted only once. It's occurring,
Okay.
and
Yeah.
in this way you will be able to do it, right? You could have also used an another map for this.
Yeah.
I thought that you were using an another map. That is why. So any other question that you have besides this?
uh no, I understood this code.
Okay. So coming to the feedback part for this interview, so I would say that you have good problem solving skills, because I could see from your resume, like you have made a lot of projects, you have participated in good events like Flipkart Grid and Facebook Hacker Cup,
Hacker
and
cup.
apart from this, yeah, right, Google Hashcode and a lot of other contests. So your coding is good. Apart from this, you have also done a lot of development from your side. So, and today, like for the first question, you were able to implement it in both the ways. Like you did it, implemented it first of all using the top-down approach. After that, you implemented it using the bottom-up approach. And apart from this, you were very close to solving this answer. Like if you had, I think, 5 more minutes, if I had given you some more time to think, might be you would have been able to do this question completely in the optimal manner. So I think your coding skills are good, and surely in future, like you will be getting some good internships or placements in some big companies.
Thank you.
So this was it for this interview. I'll just like to call Sheel to take the lead from here.
Okay, so thank you, guys, for this amazing webinar today. And Smriti, I hope this will help you in your future interviews, and you learned a lot today.
Yeah.
Okay, then I'd be ending the webinar now. Thank you once again. Bye bye.
Thanks.
Thank you. Bye.
So that was Smriti, and she did wonderfully today. Also, if you want to be a part of our future webinars, be it interview preparation series or DSA live mocks, you can check out the links in the description below. That's it from my side. I'll be back again with more webinars. So stay home and stay safe as the cases are increasing again. Bye bye.